Hello, you wonderful people. I'm here with Rich and Alex, and today we're going to talk about Strapi best practices for high performance. Hello, Rich. Hello, Alex.
Hello.
Thank you for being here.
So, Strapi best practices for high performance. My name is Alex Bennett. I'm the implementation manager here at Strapi, and I'm here with my colleague Richard Masama, who's the senior solution engineer. The goals of the workshop today, ultimately, we're going to try and identify some common performance bottlenecks in Strapi applications, find out how you debug Strapi queries in real time, which is super handy when you're trying to improve performance. We're going to optimize your content structure for better performance as well, which will allow us to write efficient API queries and custom code. And ultimately, we're going to talk about applying some best practices to your own Strapi content. We're going to look at this in two sections. The first section is content architecture optimization. And largely in this segment, we'll identify an existing content structure that was sent to us at support. We've, of course, obfuscated this, but we've kept the core content structure in place. We're going to identify how we can improve this content structure. So when we look at the example, you'll see that it's quite a bloated schema, which requires expensive front-end queries and ultimately creates a complicated user experience for both your content editors and a developer experience for your developers. We're going to make this schema clean and reusable. We're going to be abstracting from content, and we're going to make it easy to understand for content editors and developers alike. We're also going to be doing a hands-on performance walkthrough, and in this section, we're going to be talking around a common practice that we spot in the community and with our customers on using populate deep methodologies. This will then lead to inefficient front-end queries and ultimately create poor customizations. So we're going to be streamlining some of these API queries, optimizing some front-end data fetching, and creating efficient custom controllers and services. So what do we mean when we talk about performance in Strapi? Well, Strapi is just at its heart a node.js and React application. So like any application, your performance is affected by quite a variety of factors. You've got your standard candidates, things like your response time, your resource usage, your database efficiency, compatibility, content structure, optimizations, your overall schema design, and whether you've made your project scalable or not. These similarly apply for any type of application that you're building. But let's quickly set up a demo, and you can follow along with this if you want, but we will be going through mostly a slide deck today. We do have a little demo that you can find and download here. And what we've done is we've taken our Launchpad demo project, which is our best practice project, which is a really nice brochure site put together by the team. And we've made a few adjustments to it. So go ahead and pause the video and grab that GitHub URL and get that project cloned to your local machine. Let's get set up. So you've cloned the project to your local machine. We want to create a fork of this ideally. And you're going to be opening the README, and ideally you're going to be reading the README. So if you want to go ahead and do that now, feel free to skip ahead a little bit. But we will go through it step by step for those who are new to Strapi. First of all, fork and clone the repository using the command that's on screen. Then we're going to navigate to the folder that you've just pulled down from GitHub, and we're going to be creating our environmental variable files. So you'll see that there's a .m.example included in the project. Basically, you just want to rename that to .m, and you want to make sure you're doing this in both your Strapi instance and the Next.js instance as well. Once you've got your environmental variables set up, you're going to want to start your Strapi project. Now, it's super easy to start a Strapi project. All you've got to do is cd into the Strapi directory and run the command that you see on screen here. This will run a seed command that we built into our Launchpad project, which will migrate data directly into the demo instance for you. And it'll also spin up your development instance. The next thing, in another terminal window, you're going to want to start your Next.js project. So just cd into where your Next.js project for the Launchpad workshop is, and run the command that you see on screen. Again, this will just install the dependencies, build the project, and start it up. Launchpad should now be running, and you should see both front-end and Strapi instance, and a Strapi instance that is already populated with content. And we'll look at some improvements shortly for this. So let's talk about content architecture optimization. As I said earlier, we've got a real-world example. An enterprise customer sent us this a few months ago. We've obfuscated the data, but we've kept the overall content structure. And effectively, they came to us with a question asking for every array field in our Strapi project. It's leading to them creating separate components, which ultimately leads to a lot of components and a bad API response. So you can see on screen a little GIST URL. Follow that if you want to see the example schema. And again, we will be running through it in the presentation. But what you'll notice if you do look at this initially is that there's a lot of redundant components in here. Now, these may be essential components for their front end, but ultimately, when we boil it down and abstract it away from the content, you'll see that there's quite a lot of redundancy in the schema that they've set up. And this is just for one content type. And you could probably imagine that the larger their Strapi project is, the more content types it have. This is a problem that becomes exponentially hard to deal with and ultimately leads to quite an unmaintainable project. You'll see that there's inconsistent naming. There's quite a lot of use of deep nesting, and there's quite a lot of field name confusion. This isn't wrong. Their Strapi project would work, but they are encountering bottlenecks, performance bottlenecks, and we can trace a lot of these problems back to how they've set up their schema originally. So we can do better. So let's have a look at it. So the problem here is component proliferation. You've got a bunch of one-off components that are basically doing the same thing. They've got the same content structure. They've got the same type of fields, even if those fields are named differently. When you abstract away the content from the actual schema, you'll see that we can do quite a lot of improvements here. So the approach that they've taken here is design-driven content. You can see that their content type is just full of one-to-one reflections of what their UI no doubt look like. And again, it's not wrong, but it could be better. So content types built to mirror specific UIs tightly couple the front end to the CMS content type, which kind of defeats the whole point of going headless. We'll recap, if you've got it on screen, the pain points that we found examining their content type schema. So we've got redundant components that ultimately equal redundant code and redundant testing if you build testing into your project. Editors have to scroll a mile to find the right component to edit. This is in the content editor experience. We've got a tool, Dynamic Zone, which would make that much nicer. There's inconsistent naming. So the example provided here is know your coverage versus know your coverage single. These are two components that basically do the exact same thing. One is an array of the schema, and one is a single use of that schema. But it's effectively duplicating the content schema created on the content type. We've also got deep object trees, so that makes your REST and GraphQL queries pretty brittle to change and also take a performance hit. And we've got the problem of small change in this particular content type ultimately leads to bloat in the code base and in the front end and how the front end renders these components, which means any small change ends up becoming a big change. So what we're going to do during this refactor, we're going to implement dynamic zones in Strapi. So we're going to start the content creation using dynamic zone at its core. We're going to abstract away the content from the components, creating a sequence of agnostic content blocks. We're going to implement a rule where we go 2-level max deep in the nesting. Again, this is taking performance into consideration. We're going to be creating a bunch of shared atoms that you could then use in other content types throughout your project. And we're going to implement some consistent naming. So the first thing to do is we're going to be identifying the little patterns. And you'll see here that I've highlighted that we've got a component, CTA link inside of Know Your Coverage. And inside Ensure Now component, we've got a link component, which is effectively 3 CTA components that are all doing the same thing, but they're all named differently. And ultimately, in this singular schema, we've got 5 names for the same content pattern. So the fix that we're going to be implementing here is we're going to be taking all of those instances where there is a need for some target URL or some link to be output in the API to be rendered by a front end. And we're going to collapse them down into a single shared component, which we're going to be calling button. We're going to also be looking at the cards in the project. So they've got quite a lot of content cards featured in quite a lot of the content components. You can see here that we've got cards in all of these individual components here, which are basically, again, all using the same structure. And it's creating quite a lot of chaos in the content type. So the fix here is component amalgamation, where we're going to take all of the shared attributes that we found on the content type, and we're going to squash them down into a single component that handles the content in the same way, but again is agnostic from the actual content, agnostic from the design. It is just a schema to serve the content that you need to fulfill the requirements of your content or your design. And you can see here that the new component is itself using some new shared components, some atomic components. A component like copy would be useful if you've ever got the pattern, title, and then some WYSIWYG content. So we're building it out now with a sequence of shared atomic components and our actual content blocks. So how are we doing so far? We've had, in this refactor, we had 5 original components that we've all merged them into a single component now called cards grid. We're going to look at one more example. So we had this instance where you've got know your coverage and a single instance of the know your coverage content schema. And we're going to, again, squash these down into a singular component, but we're agnosticizing it from the content. So this pattern we've identified is a question and answer pattern. So again, we've created an atomic component to handle that content schema for us, and then we can make use of it in our new, what we're going to be calling our FAQ component. And again, the naming of these components is largely to try and abstract away from what the original concept of the content type was trying to do, which when you read the original schema, again, is very, very tightly, closely tied with the design. So one of the things I want to highlight as part of this refactor is we haven't tried to make an exact one-to-one copy of the schema, especially in this particular use case. And the reasoning is outlined on the screen here. The reasoning I gave the end customer is outlined here. And again, it's to try and help them understand the idea of abstracting away their content types from their actual content or from their design. So we've got a new content type schema now. And as you can see here, it's super short. We're making use of our dynamic zone component. And ultimately, the end API output will be largely exactly the same. They'll obviously have to rewrite the front end querying this content now. But again, as we've amalgamated quite a lot of the noise in the original content type, they can now go through an exercise where no doubt they can clean up the front end quite substantially as a result of this refactor. So the performance wins that we've achieved here by just reorganizing our content schema is we've gone from 14 content components down to 5. So that's a lot less to maintain in your Strapi instance. We've reduced the overall API payload, all the noise that the original content type schema created by about 38%. And in our GraphQL resolvers, we've gotten rid of about 50% of them. So we've taken a lot of blowout of the Strapi instance, and we're still able to serve the same content through the API to be consumed by a front end. So the original content pattern that we had, we've now consolidated and amalgamated it down to several components, both atomic components and block level components that we've made use of in a dynamic zone. And we've adjusted the schema overall to produce the same API output with much less complexity and hopefully much less confusion for content editors and for new engineers joining the project. So now I would say to the customer, it's time to refactor your front end following this new pattern. So what's the takeaway from this? The takeaway is, ideally, when you're building a headless solution, you don't want to map your content types and your content components, however it is you're building your content schema, directly to the UI design. Think about it more abstractly. What does the UI need in terms of the primitives for each of your content types and for each of the fields in those content types? And you will start to spot repeating patterns in your UI that if you then tightly couple the naming convention, for instance, of your UI design component to your content component within Strapi, it could create confusion when that content component is used elsewhere. So one of the takeaways I will try and leave you with here is, where possible, try and make your content and your content type schema in Strapi as agnostic as possible when it comes to the actual content and how it's used in whatever front end consumes your content. So decouple the schema. Next is merge.multiply. And for this, you notice that we took a lot of the noise in the original schema and we identified those repeating patterns so that we could create a series of smaller, more manageable components that were then used in our larger level block components. And for the keen-eyed amongst you who have been reading through the presentation slides, this is largely borrowed from Brad Frost's concept of atomic design. A lean schema is ultimately a fast schema. When you've got a less complicated schema in Strapi, ultimately it means that we've got fewer columns and a flatter JSON. We've got simpler resolvers, and every request payload is ultimately a little bit smaller. It's easier to cache, and it's quicker to serve. So those are the takeaways I want to leave you with. And finally, I'm happy to announce as well that we're introducing a feature soon, which has been long awaited CMS upgrade, which will help you tidy up your content types for both the developer experience and the content editors alike, and ultimately, again, assist in how you structure your content types. So the engineering team is already deep in the scoping phase, and we will be providing updates as and when we have them. But I'm happy to announce that conditional fields are coming to Strapi sometime this year. So I'm going to hand over to Richard now for a hands-on performance walkthrough.
Okay, thanks, Alex. So as Alex mentioned at the beginning, my name is Richard. I'm a solutions engineer here at Strapi. So I'm going to be walking you through some hands-on performance scenarios with Strapi, and just to give you an understanding of some of the do's and don'ts and how you can improve your own projects and your own customizations within your own projects, and also some tools to help you debug some of the issues that you may face going forward with your projects. So let's go ahead and start identifying some potential issues with the examples that we've prepared for you today. So the first issue that we have presented for you here is a query, right? It's a Strapi query, and there's a few problems that we have with this. In Strapi 5, we have some facilities that allow you to make queries to the database and not have to do some extra heavy lifting, right? We have what is now called the document service. Before in Strapi 4, we primarily endorsed the entity service, which is now getting deprecated in Strapi 5. So if you notice here, there's a few things that have been done that aren't exactly the best practices. The first thing is the first line of this example, which is querying data from the database, particularly in the articles collection type, is using the DB engine as opposed to the document service. The difference between the two is the document service adds a layer of various things on top of the DB engine. One of them is security, sanitization, as well as some more intuitive ways to fetch data, field selection, population, so on and so forth. And you will notice some of these things here. If you have a look at this query, you'll notice that we're trying to fetch all the records from the articles table. Now, there's a few problems with this. Let's assume you have quite a lot of records in this collection type that you're trying to query. Ideally, you're going to be querying this data without paginating any of it. You'll be attempting to fetch absolutely everything, which is not the most efficient way to go about these things. The second part of this, which is the second line, I'm creating a list of this data and picking out particular fields in this data. This is also an additional issue. One of the problems that you're going to face here is, again, let's assume that the data set that you got back from the first call was really large. You're going to have to map over a very large data set, which, again, it's not only are you going to have to create a new data set, right? You're creating a new array essentially by mapping. You're then assigning it to another variable, which in this particular case is not necessarily the best use of your memory. The other thing which I also alluded to before is manual field selection. Strapi has field selection already built into every document service query that you can write, and you can utilize that because ideally what happens, and I'm going to show you on the next slide, is our document service is able to construct a specific database query that only pulls what is necessary, i.e. what you have specified from the database, saving quite a lot of bandwidth. This is the second issue, right? In here, I'm taking in external input from the server in one way or the other. And then I'm taking that external input and using it to construct some form of a custom search query. This is a very crude example, but some of these situations we have seen happen in production applications, and we like to point them out just to give people understanding of why some of these things aren't the best to do. Now, when you have a custom controller or service that is written this way, you're going to notice that one, the most important thing is you're opening yourself up to an SQL injection risk. You're not sanitizing the input in any way, shape, or form. And this could lead to quite a lot of problems for your application going down the line. The next thing we're going to talk about here is what the implications of the query that was written in the previous slide is exactly on the database. Again, aside from it being an SQL injection risk, we're going to utilize our database's query planner by prepending explain query plan to the query to have an understanding of what exactly the database is doing at the time of performing this query. Now, what you're going to see when you get the output of the query planner is you're essentially performing a full table scan, right, of this data that you're trying to query. Ideally, in some cases, some of the fields that you're going to try to query, and depending on how you're querying them, in this case, you're trying to search by slug. There may be situations where an index for the slug has not been created, and as a result, you're performing full table scans each time to be able to find the data, or to be able to search for the data that you're looking for. Again, if this is a huge data set, it can be very costly. The third issue that I have here can be broken down into two parts. One of them, again, is using the DB engine. The other way also is what I would consider as improper utilization of the event bus in JavaScript. When you look at some of the challenges that you might face in Strapi, it's very important to separate your concerns. Sometimes Strapi, or at least directly solving a problem within Strapi, might not be the best use of the program. Again, like Alex mentioned, Strapi is essentially a Node.js application on the backend, and you have to make those considerations as you're writing your solutions, your customizations. If you notice, there's an operation that's happening in the first line, as well as an operation which is asynchronous or a synchronous delay in the second line. This delay is arbitrary. I just specified 3 seconds for the sake of it, but it's just entirely an example. Strapi is inherently a Node.js application on the backend, and you have to use some of those principles of writing Node.js applications when developing your customizations with Strapi. Let's take a look at this example. We're making a possibly costly query, right, by using the DB engine. Not necessarily in this case because we're finding one item by the ID, but let's just assume that this is something that can also be costly. And then afterwards, we're trying to tweet out this issue or this article that we have been able to fetch from the database. Okay. And await sleep is supposed to be an example of maybe performing an operation that is, maybe you're sending a payload to another server and waiting for a response back from that server. In this particular case, Strapi might not be the best use for this because it's going to take or make an impact or have an impact on your user's experience. In situations like this, we really do recommend you either make sure that some of these operations don't block the regular execution of the operation, or just offloading it to a completely separate service, right? Maybe using a lifecycle or a webhook. In Strapi 5, we have document service middlewares, which would even be a bit better. But if it's a plugin and this is just an operation, you might be able to just send a request over to a separate service to perform this operation in the background without interrupting the normal execution of your Strapi application. Okay, so now we're going to have a quick chat about how to debug your database queries. In this example, it's a bit clipped, but I'm going to do my best to explain what's going on here. So we have the database connection object that you usually see in the config database TS or JS file of your application. Now, I specified one very important key at the bottom of this object, which I would like you to take a look at. It's called debug. This key is very important when you're trying to debug the performance of your database queries or the Strapi queries in general. What this key does is essentially it starts to echo out raw SQL or the raw SQL queries that are generated by various queries that are being executed throughout Strapi. It can be very useful to debug some of the issues that you might be facing with your application and have an understanding of what exactly is being done in the background outside of doing things like query planning, for example. So if you have a look at a sample output of what the debug flag does or the debug key does once you enable it, this is an example. You get to see the fact that one of the queries that were executed in this particular case will let you know that this was a select query that was executed. It's going to also let you know the exact query that was executed on the database side. In this particular case, you notice the last line that says SQL, the SQL query, key. This line is telling us that the database selected every field from the articles table, including some fields that may be unnecessary. In this particular case, this query, again, is going to perform a full table scan as opposed to maybe utilizing indices if that was necessary, or utilizing specific field selection if that was more useful, like in the first example I showed. So moving on from this, we're also going to talk about something that we see used very frequently, moving from Strapi 4 to Strapi 5 within our users. It's called depopulate. Don't use it. We strongly recommend that even as you're migrating your applications through versions, you make the most use of the Strapi facilities. In this particular case, things like field selection, as well as also making changes to the consumers, i.e. the front end side of the consumers of your Strapi APIs. So Launchpad has a current depopulate middleware. And ideally, instead of doing this in a global middleware, the best solution for doing this would be to just utilize the granular control that Strapi already allows you to have access to in route middlewares as opposed to global middlewares. So when you look at this fix, you're going to notice a few things. As opposed to it being a global middleware, it's going to be a route middleware. Essentially, global middlewares get executed after every query or with every query that is happening with Strapi, which is not necessarily ideal. Specifying it to route level middlewares can be very useful in case you want to have more specific control for some of this population. More so, a standard way of populating some things that you don't anticipate will need changing later on down the line. So thanks for coming to our talk here. We hope you've learned something. Alex, any few words from you?
Say that was really, really good. I think very helpful. I identified a lot of common things that I see in the community, which people actually, the mistakes that they make, and then they come back and be like, oh, my app doesn't seem as performant. And I think it's just when you're starting out, learning all the possibilities. I think it was amazing to have you two come on and kind of talk from the experience of actually dealing with real customers and what are the use cases and how you could increase performance in your Strapi application. So that was pretty awesome.
Thank you as well, Paul.
Sure. Thank you so much. We're happy to participate.
If you are a Strapi customer, you've got any specific issues, feel free to get in touch with us at support@strapi.io. If you're a community member and you've got any issues, feel free to drop into our Discord.
You have open office hours, 12:30 p.m. CST time, so you could jump on when you're there. But with that being said, thanks a lot, everybody.
Thank you so much.
Yep. Bye, everyone.